Welcome back to the channel. My name is Chris Puglia, and I am an analytical data scientist.
Nerd.
And I've been learning how to program over the past several years. And as I consider my journey where I was in the beginning, where I was just trying to get the code to work right, and where I am now, where I'm actually trying to do more refactoring. And that is simply put, trying to change my messy code into cleaner code without necessarily changing the output. And so refactoring has the benefit of making code easier to read, remove duplication, take out some of the bigger functions and breaking it down to simpler functions, and just make it easier to test and reuse, and including the ability to expand that code base because now you have simpler functions carrying out the tasks that you want to be done, particularly when it comes to Python. So I want to show you a simple form of refactoring, and then we're going to go to a more chemically relevant refactoring case using some data. So in my simple case, let's say we have a function whose job is to greet some person whose name. And I want to show you what that function will do. If we run greet Chris, it will say, hello, Chris, welcome to the platform. As you can see here, this code snippet is relatively simple. However, it has a couple of issues. One, it's taking my name and automatically including it into the statement, but it's done in such a way that I can't really extend this base to do more. So let me show you with this simple case how we can extend this for more reusability. So I'm going to get rid of this greet here. I'm going to comment these lines out. And so I want to create a new function called format greeting, and it's still going to take in a name. And I want to say, hello, name, welcome to the platform. Now, if I were to run format greeting, I won't get an output just yet. So what I want to do is make another function called greet, and it's going to take my format greeting and print the greeting. And so when I run this cell, greet Chris, you see that we get the same output. Let's say I just add Chris P so you can see the difference. We are getting the same output, but we have the benefit of being able to extend this code base and use it for additional functionality if we need to. But in this case, the result is the same. So let's go to a chemistry example where there's a bit more sophistication and it's a bit obvious where we're perhaps overloading this function. So in this example, I have some code that has too many responsibilities, and I'm using numbers where it's hard to necessarily derive where they're coming from. And so in this function, outside of not having a doc string, I want to analyze peaks, so it will take in some data. I'm going to set a threshold for presumably peak picking, but I'm also going to offer the ability to normalize the data and then sort those peaks. So the data argument will be passed through. It'll loop through this filtered list comprehension, and anything above a threshold will be considered a peak. And then it will normalize if this normalized value is true. Right now is defaulting to false, so it will skip this if statement. Sort as defaulted to false, so it will also skip this if statement, and then it's going to return the filtered data. So if I take my raw peaks here, you can see we have 10, 200, 5, 325, and I set my threshold to 20. And I pass in analyze peaks, and I pass raw peaks. And let's even normalize and sort the data. Although again, it's unclear what this normalize and sort would mean in this context. I run this cell, and then I run this cell. You see, I have some peaks. They are normalized and they are sorted. So let me actually remove the normalization just so it's even easier to see what this is doing, as well as getting rid of the sort, because in this context, it doesn't make a lot of sense. And we can see we have 3 peaks based on this threshold of 20. We have a peak at 200, a peak at 300, and a peak at 25. Now, this code is perfectly fine, particularly if you're in the early part of your journey, but it is important to understand that this code is doing a lot of work. We're normalizing, we're sorting, and we're doing some preliminary peak picking. And so it can be hard to test this code. It can be hard to extend the functionality of this code because I might want to normalize without sorting, but then apply some other scaling. Let's say I want to log scale my data instead, or do something different where I would rather break these out and be able to use them in a more modular fashion. And so let's refactor our code. Here you can see we have 4 major functions. We have a filter peaks function, which would take some data and a threshold, as we saw before. In the next function, we have normalize peaks, which you just set the normalization to the maximum data point. And then we have another function for sorting our peaks here, which is just going to use this sorted method. And then lastly, we're going to use the analyze peaks pipeline, and we're going to pass in that same data, which would just be a list, and then steps. And so I'll show you what steps is in the next cell, but here we're going to treat each of these as steps in some peak picking, peak formatting, peak scaling process. And so lastly, one of the tools that I don't use very often, because I'm usually operating in a pandas work process, but is in functools using the partial function. And what this allows us to do is just pass in functions in a way that's analogous to the pandas data frame pipe method, where we can actually stitch these together as steps, where we're going to use our filter peaks with a threshold, and then we're going to pass in normalize peaks and sort peaks. So it's just going to pass the output of one function as the input to the next function in this stepwise process. And then you can see here, we can modify this by commenting out these steps or even including new steps. For instance, if you want to log scale these data or perform some additional functionality as it relates to a particular project. And so with the same set of steps, we will pass in our analyze peaks pipeline, which will take in our raw peaks and our steps. And then we can print this output. So we're going to pass in the same raw peaks list, and you will see the output here. And once I run the cell, you can see that we're getting our normalized output there. So let's say in another example, we don't want to normalize our peaks. We can modify our steps. So note, this is just a list. We can comment out whichever processes we don't want. Instead, let's say I don't want to normalize and I don't want to sort. I can just comment those out. I can include them if there are steps that I want to include. And this is the benefit of using this more modular functionality by refactoring the code. We're maintaining the same output, but we're allowing our code to be easier to read, easier to maintain, and easier to extend if you want to add new steps. If you found this video helpful, like, comment, subscribe, and I'll see you in the next one. Peace.